Quantum Physics for Beginners, an easy guide for discovering the hidden side of reality, one speck at a time. Written by Darrell Ason, narrated by Wright. Disclaimer: the following manual does not claim to be exhaustive in all the breadth and facets of the subject. Some of the examples illustrated are the most known and easiest to grasp in the field, and a myriad of other examples and cases have been deliberately discarded in order to make this exposition the most accessible to everyone regardless of their level of study. The exposition may therefore be reductive and simplistic in many of its parts for those who already have a good level of knowledge of physics. For these people, other types of text or audiobooks are recommended. All efforts have been made to make the content accessible and enjoyable by purging it of complex formulas, which would require a greater level of preparation to understand them, while maintaining the key concepts essential for understanding the subject. Welcome. Welcome to Quantum Physics for Beginners. Does the thought of learning quantum physics make you want to curl up in a ball and cry? Then you have come to the right place, because we're here to wipe away those tears and turn that frown upside down. We're going to take a real-world, relatable look at the science behind the tiniest pieces of our universe and the scientists who study them. Part of the reason quantum physics is so intimidating is that the subject is often fraught with indecipherable formulas and fancy terminology that leaves the average human scratching their head and throwing up their hands. So go ahead and use those stuffy textbooks to prop up the uneven legs on the table you inherited from Aunt Sarah and Uncle Joe. Sure, we're going to have to tell you about some of the math, but we promise it won't be painful. Even better, there won't be a test at the end. Just sit back, relax, and come on a laid-back, sometimes irreverent, ride that will take you from the discovery of the atom to the astonishing science of the greater universe. We're going to take a look at some of the most brilliant minds that ever graced a laboratory, the experiments they developed and presented to the world, and why sometimes even these geniuses were misguided in their pursuits. Quantum physics strives to recognize and explain how the universe's tiniest pieces all fit into the big picture. If there comes a time when human beings can journey to live on other worlds, it's going to be because of quantum physics. If we ever want to travel through time, it's going to be because of quantum physics. And if you have no interest in those things, but you'd like a teleporter to get your errands done a little quicker, you guessed it, it'll take some pretty solid quantum physics. Yes, these things all sound more like science fiction than science fact, but have you ever read any good old pulp sci-fi? Some of that stuff has already come true, so there's always hope. The point we're trying to make is that quantum physics isn't something you need to be afraid of. As you work your way through the audiobook, you'll realize that the scientists who founded and continue to study quantum physics might be wired a little differently. Looking at you, Schrödinger. Still, they're human beings who want the same thing as you, to know and understand the nature of the world and the vast universe around us. Chapter 1. Introduction to Quantum. Scientists didn't just wake up one day with a laboratory full of fancy electron-scanning microscopes and mass spectrometers. It took years of discovery and experimentation to get to the understanding of quantum physics that we have today. The story of quantum physics, which holds a dictionary definition of the branch of physics concerned with the quantum theory. Helpful, huh? Begins with the story of classical physics. This, of course, is the scientific discipline that aims to use mathematics and mechanics to explain how the world works. So where does the fundamental split between classical and quantum physics occur? The truth is, there is no specific date or definitive line that shows us where classical physics ends and quantum theory begins. Like a snowball rolling downhill, the theories that would evolve into quantum studies started slowly,
Sample complete. Ready to continue?